Hello boys and girls, this is Mr. Kizik, and in this video we're going to be looking at how do we find missing sides of right triangles. So in the previous lesson you looked at how to find the ratios of a right triangle, but now we're finding the missing sides. So the first thing you need here, and basically the only way that you can do these problems, is if you have a calculator. If you have an Android phone or a scientific calculator or a graphing calculator, all of those will work. However, if you have an iPhone, it can still work. However, you would have to do the things backwards. So if you do have an iPhone, I would recommend not using it. And in fact, I would find a different calculator. If you do not have access to a different calculator, you can always go online here to scientific calculator. The thing you want to make sure is that, as it says on here, that your calculator is in degree mode. If you have one of those basic scientific calculators like we had at school here, when you turn your calculator on, there'll be something on the bottom that says DEG, DRG, or I think it's RAD or GRD, something like that. You want to make sure DEG is highlighted. If it is, great. If it's not, you want to press the DRG button that's on the calculator and keep pressing it until DEG is highlighted. If you have a graphing calculator, what you want to do is you want to press mode, and then I forget, it's the third or fourth down, I forget which one it is, but you'll see that radian, the options of radian and degrees. If radian is highlighted, what you want to do is arrow down and then arrow over and press enter, so now degrees is highlighted. All right? The way you know that you are in the right mode is this. It's a little trick to help you. So I'm going to use it here. And, this is something that I just know here. If I press sine of 90, so see, I didn't get it. I'm not in the right mode. So there you go. So if I did sine of 90, I should get 1. And if I don't, if you get like that other thing that was mentioned, then you know you're in the wrong mode. All right, so now how do you do these problems here? So what you want to do is everything is related to the angle measure. So here's my angle measure, 28 degrees. We do not relate it to a 90-degree angle because, as we talked about in the last video, that is its own special thing. So we want to figure out what is the relationship between the sides and the angle that's given. So what you want to do is, well, we know 19 here is the hypotenuse. What is x in relation to 28 degrees? Well, from what we did in the last video, if we were to draw an arrow here from the angle to the side, that means it's the opposite side. So which trig function deals with opposite and hypotenuse? That is sine. So what we want to do now is set up our little ratio. Sine of, I'm going to use a symbol theta. Theta in math means angle measure when we're dealing with triangles. So sine of theta equals opposite over hypotenuse. Now what I'm going to do is fill in the blank with numbers and variables. So sine of, what's the angle measure? 28 equals the opposite side, x, over the hypotenuse, 19. Now what you want to do is just use algebra and solve for x. How do I get x by itself? Multiply each side by 19. So x equals 19 times sine of 28. And that's all you can do by hand here. The rest of it is using the scientific calculator. So on the scientific calculator, I'm literally going to type in 19 times sine 28. And you're going to get a decimal as your answer, so as the problem says, round it to the nearest tenth. So that would be 8.9. And that would be your final answer. I would not write it as sine 28 times 19 because this sine 28 here is one whole term. They go together. And I see students make this mistake many times. They go to the calculator, type this in, but then forget to put the parentheses and then put times 19. What the calculator is doing, again, it's only as smart as whatever is put into it. What the calculator is doing is taking 28 times 19 and then taking the sign of it or the ratio of it. Let's look at another example. Let's look at this number 2. Here's 41 degrees. What is the relationship of these sides in terms of that angle? Well, if we drew an arrow, this is the opposite side. This is the adjacent side, right? Because it's right next to it. So which trig function deals with opposite and adjacent? That would be cosine. So cosine theta equals my mistake here. Thinking of the next problem. Opposite and adjacent is not cosine, is what? Is tangent. So tangent of theta equals opposite over adjacent. Now let's fill in the blanks. Tangent of the angle measure, 41, equals the opposite side, which is x, over the adjacent side, 32. Do math. Multiply each side by 32. So I get x equals 32 times tangent 41. I now go to the calculator. 32 times tangent of 41. And I get around 27.8. Now let's look at number 3. What is the 21 degrees is right here. What is the relationship of the sides with that angle? This is the adjacent side. This is the hypotenuse. So now, what trig function do we use that deals with adjacent and hypotenuse? It's cosine. So cosine theta equals adjacent over hypotenuse. Fill in the blank. Cosine of 21 equals x over 26. Do some algebra. So x equals 26 times cosine of 21. And now we go to the calculator. 26 times cosine of 21. And I get around 24.3. Let's skip number 4 here and look at one like number 5. So again, here's a 33 degrees. What's the relationship of 15 and x to that angle measure? 15 is the opposite side, and x is the hypotenuse. So which trig function deals with that ratio? That would be sine. Sine is equal to opposite over hypotenuse. So now let's fill in the blanks again. Sine of the angle 33 equals opposite 15 over the hypotenuse x. Notice how this one's different. This one's different because now x is on the bottom of my fraction instead of on top. This is still algebra because how I get rid of fractions, multiply each side by x. So x sine 33 equals 15. Well, I still need to get x by itself. So what I have to do is divide each side, not just by 33, not just by sine, but sine of 33. So in the calculator, this is what I'm going to put. So 15 divided by sine of 33. And I get around 27.5. So notice that little difference there. When x was on top, it was just multiplying both things. And when x is on the bottom, then it would be 15 divided by sine 33. And again, that's based on the algebra there. I will do another one as an example. So this 43 degrees, what's the relationship with the sides? This is the adjacent, that's the hypotenuse. So the trig function is cosine. Cosine of 43 equals adjacent over hypotenuse. Solving for x, I get x cosine of 43 equals 36. Divide each side by cosine 43. So x equals 36 over cosine of 43. Put that in the calculator. And I get 49.2.